On our calendar, yesterday's goal was to start section 2.6, and I think we did a pretty good job of that. Period 6 is a little bit behind us. They're going to have to catch up today after being gone for extended lunch. Anyway, we'll figure it out. And then you guys, make sure that I give you at least 15 minutes at the end of class. It should probably be 20 so that we can be even with period 6. They're going to come in 15 minutes late from lunch. So that's why I need to make sure that you guys have that extra time. So there we go.
We'll just use that. That's always better. That's like $50. Wait, can you use the number 2 pence?
Tomorrow, when the kiddos come back.
Really?
Stop judging.
No, I'm not just
She said that she always uses them, so her parents will buy her any more mechanical pencils.
Such a good. Thank you, Miss Owen.
I'm just like, I didn't know people still use number 2 except for the SAT.
So, this is fun. Coming back. Tomorrow, when the juniors come back, we are going to go ahead and do a little bit more section 2.6a, like AP practice kind of thing, but just like a few examples to show them the idea to say, here's the forever card. So that's why our homework isn't due until Thursday, technically, on this section. But you guys, my advice is to get a really good start, aka like finish completing it by tomorrow, so that way we can just do a couple more examples, and then you guys can get started on 2.6b. But I'm doing this little finishing 2.6a for the little juniors. Sorry, the juniors. I'm sorry. Alright, let's go ahead and watch HCTV really quickly. I'm going to go ahead and pause the video because juniors, even though you should know what's going on, it's not super important, so let me pause that. The backboard, this homework is not due until Thursday. However, theoretically, after today, you should be able to finish it. This is going, that's what I was doing. This is going to be a forever card. I'm going to go through. Yeah, this memory thing. Hold on. There we go. Now, you guys know what the forever cards are in your folder, right?
Yeah.
Class notes. Dun-dun. Forevers. Dun-dun. Okay, let's go peek at the forever from last year to see how I stated this derivatives of the inverse. It's going to be right here. It's actually in the CalcBC folder if you guys ever want to see all the forevers from last year. But do remember, I've changed up a few things. I usually do. Where did it come from? Oh, there. As it's loading, so inverse functions. Do you remember what the relationship is with an original and an inverse? What's true? Something, anything. It's a reflection across what line? Y equals X. Okay, what else? Algebraically, how do we find an inverse?
Switch the Y and the
Switch the X and Y and solve for Y, but what's the notation for an inverse? The -1 as the exponent, but technically it's F inverse, not F to the -1, not a reciprocal, right? What else do we have? What happens to the domains and ranges for inverses? They switch as well. Okay, so all of that leads us up to, let's see, where are we at? We've already talked about that one. Aha. Okay, so it is, I do not put a lot of detail on that, that's totally okay. The other way, we're going to put a quick note on our forever card this year. You can switch the X and Y and derive implicitly. I'm going to add one quick little note. Remember I said yesterday there are two ways of finding these derivatives. One way is to switch the X and Y and to derive implicitly. But the other way, which the AP sometimes forces your hand, the other way is to use the formula that we have listed up above. Guys, literally, I am taking this, I'm taking a picture of it. Ew, I don't like the red circle around the B. Give me 1 second. Let me get rid of the red circle. Oh, and my yellow box. This is so sad. Forever card number. Dun dun dun. Line color. Where are we at? 50?
Like go outside and take notes on the book. It's so cold.
Oh no, hold on. Oh, it is 17. Good call. Okay, so forever number 17. The derivative of the inverse And there we go. You guys got it okay?
It looks very weird because the lines are interrupted.
17.
29.
I don't get it.
Steve, off the top of your head, what is Forever 29?
I have no idea. I'm not memorizing my numbers. Lo siento.
Just show you.
And the numbers are different this year. So much pressure, you guys. Okay. So now we have our rule. We need to use it. Now we have our rule. We need to use it. So, yesterday, we did this really quickly, but did you guys get it down?
I didn't understand it.
Okay, so pause. I'm going to go ahead and do a couple of things really quickly. I'm going to move this down. I'm going to show you where some of this came from. Okay? I'm going to do two things. First of all, I'm going to see the 1/2, and I'm going to see the original function. So, if A is 1/2, let's look at our forever card really quickly. Our forever card says, F inverse of A equals B, or F of B equals A, right? F inverse of A equals B, or F of B equals A. So for our rule, we need to figure out for the inverse, if A is 1/2, then what is B? If A is 1/2, then what is B? For our rule, we have to figure out a point. So if they give us 1/2, okay, cool. My question to you is, if they are asking for F inverse of A, is A an X value of the inverse or a Y value of the inverse?
The inverse?
Of the inverse, it's an, what goes in the parentheses? X. F of X, F inverse of X. Now this looks weird. Hold on, pause, guys, this is not multiplication. Look up here, look up here. Ah, my non-math peoples, there are multiples of you. Put it away. A is an X. This is not times, this is up. So F inverse prime of A is an X value of the inverse. What does that mean about the original? If it's an X of the inverse, then it's a... So we have to set the Y of sine of X equal to 1/2. Now, question, how do we solve for X?
You take sine
Sine inverse, but you can't use your calculator. So what's the idea of sine inverse?
going back.
Going backwards, unit circle. Going from when the coordinate is 1/2 to the angle. What's the angle in between negative pi over 2 and pi over 2? That's the fourth quadrant and the first quadrant. At what angle will the opposite be positive 1/2? Pi over 6, where cosine is root 3 over 2, sine is 1/2. So I know that x equals pi over 6, which means b is pi over 6.
So we just got the inverse of sine?
We got the inverse's point. Does that make sense? So we solved, if this helps, here's another way of looking at it. Another way of looking at it, which doesn't change the math at all, but you could think, wait, the inverse switches, so his x is over here and his y is over here. So I needed to plug in the 1/2 as x to find the inverse's y.
Oh, so you just solve it from there.
Does that make more sense? Yeah. So then we switch the x and y, that's the inverse. So the x, the 1/2 goes here, we have to solve for the y. We figured out, I'm sorry, it's not 1/2. What's the angle again?
It's
Pi over 6. So then now we have, if you want to think about it, the a and the b. We have the x and the y of the inverse. So then as we go down to the bottom, our rule says f inverse prime of a equals 1 over f prime of b. Well, who is f prime? That's something that we haven't done yet. F prime of x, not f inverse, f prime. What would be the derivative of sine? So then when I go to plug into my f inverse prime of a equals 1 over f prime of b, all I have to do is say, okay, fine, f inverse prime of 1/2 is 1 over f prime of pi over 6. Take f prime cosine and plug in pi over 6. We've already talked about the unit circle, so actually I already have the cosine chilling right up here, root 3 over 2. Well, 1 over that would be the reciprocal, 2 over root 3. But, guys, I think the back of the book, someone said they rationalized. How would you rationalize that answer? Yeah, so you could also have 2 root 3 over 3. So how did I build up to solving? Yesterday I just said it all verbally and it was super fast. Today I said, cool, I have an A, I need a B. So I switched the X and Y, and I went ahead and figured out my B. I figured out the Y value. I figured out who F prime is, and I put it all together in the formula. 1 over F prime B is cosine of the B that I found. Done, done, done. Okay. Now we have some more examples because these get really tricky really fast. And this rule is kind of hard to follow. So let's do another example with switch X and Y, solve for Y. Ooh, don't do that. Bad idea. The last one we kind of could, this one we couldn't.
Just switch X and Y.
But you can switch X and Y. I'm not so sure you want to solve for it. Just a few of you might want to think about, could you get Y alone?
Wait, for this, like, we're in the back. It's just us.
Just switching X and Y. I mean, yeah. And the reason I'm doing that is because A, where does he go for the inverse if he's in this spot in the direction? Does he go in the X or the Y of the inverse? He goes into the Y of the original, which is the X. Yeah. Does that make sense? Yeah. So if we're thinking about the inverse, remember we're trying to fill in 6 is the X, who is the Y, so let's put 6 in the X spot for the inverse. Now here's a struggle. I thought we couldn't get Y alone. How on earth are we supposed to solve? Not derive, we're just trying to figure out who the Y is. We're trying to figure out B.
No calculator, right?
Can
you multiply Y?
If we plug 6 into the original, he'll go in the exact same spot because the X of the inverse is the Y of the original. 6 is only an X of the inverse.
If we multiplied that entire side by Y,
We could multiply everybody by
so you
Y.
get 6Y equals Y to the 4th minus 4. And then you add 4 and then subtract 6Y. I guess.
You get it all
and
to
you would
one
get
side and you factor a nasty quartic polynomial? No. Yes, you could. I mean, factoring is a thing. You learned it in section 2.5 of last year. You have to do synthetic division. You have to try out all the different zeros and see. But let me tell you something nice about the AP. There aren't many things, but this is nice about the AP. If they give you this, and it's a calculator problem, couldn't we graph this guy as y1, this guy as y2, and find the intersection to see where they equal? We could cheat and use our grapher. We could even subtract the 6 and find the 0. However, these are rarely graphing calculator problems. So you're like, well, how on earth are we supposed to solve it if y is always a nice number? AP, y is always a nice number. Meaning, start plugging in stuff and see if it works. What? Mm-hmm. Plugging in like what? I don't know, 0 is a nice number. 0 minus 4 over 0. 1. 1 minus 4 over 1. 2. 8 minus 4 over 2. It's always a nice number. All you gotta do is just plug in a few until you find it. If you get to 3 or 4 and it's not working, maybe try -1, -2.
Does that work technically lead there?
On the AP.
Even though it's an enormous
It's-
jump algebraically, if you were to actually be solving it algebraically, but
Oh, it won't be an FRQ, it'll be a multiple choice.
oh, okay.
It'll be a non-calculator multiple choice. I can almost guarantee. So then it's always a nice number you can plug in. Now pause one more time. If it was like a nasty decimal, you'd be using your calculator. You could move the 6 and find the 0, or you could graph this one and that one and find the intersection. You could use your calculator. But on this one, plug in 0, plug in 1, plug in 2. Oh, there it is. Dun, 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 dun. Now, who is that? The B. Okay, this was all just to figure out the inverse. What does my formula say for finding the derivative of the inverse? F inverse prime of A is 6 equals 1 over, what's the formula? F prime of, who's B? Who do we just find? 2. Oh wait, who have we not figured out yet? I need F prime. Okay, so let's go find F prime. It's not horrible, but would you guys rewrite? I'm gonna move this down so we don't know F prime yet, so let's come back. That was all the inverse, let's come back. Who's F prime? Oh, wait. Some of you might be able to mental map it, but some of us might not be there. How should we maybe rewrite this to make it easier to derive?
4x to the negative 1.
Yeah, could you do quotient? Bottom to top minus top to bottom over bottom squared? Yes. What ends up happening? The same thing that will if you were to rewrite it, 4 times x to the negative 1. Now let's do f prime of x. Our brains don't think in negative exponents. So write it in a way that you would understand. 4 over x squared. Now, we're just plugging in a number, so do we really have to make it gorgeous and pretty and simplified? Not really, you just have to be careful. So we're going to do 1 over 3. Now we plug it in 2. Is that okay? Cool. So then I see 4 over 4 is just 1, right? Double check me, but I think it's 1 over 13. You guys mental math? 2 squared is 4, 4 times 3 is 12, 12 plus 4 over 4. Okay. So what was our work? With F, we find F prime. With the inverse, we go looking for B. We put the two together with 1 over F prime.
So is this one of these things that like you could just follow the steps and always get the answer?
The only trickiness is right here if it was a decimal. If it wasn't a nice trizero, I know it's nasty, but just experiment. Test different things. If it was a nasty decimal, you just have to use a calculator. Now, Tyler, as far as the algebraic jump that we're making, technically you could go ahead and get the quartic polynomial and go testing the zeros, factor it out, and you would find this is the only real zero.
Is that the only way to...
Algebraically solve. The derivative of the inverse. 1 over f prime of the original. Now, what was the note that I had you guys write down in your forever card though? Now, I don't want to totally throw all of you off, but I do want to show you what the note means. I'm going to take this exact same example, which I solved very similarly to this example, right? We found f prime, we found b, we did 1 over f prime of b. I'm going to solve it with the note. And the note would say, take this function, this is the alternative way. This is solving with the note. There you go. If you were to take the original, and if you were to switch x and y, you would still have to do your sticky inverse thingamabob. But look and see what changes. You could switch x and y. And now this is the inverse. I don't have to get y by itself to say it's the inverse. I switch to x and y. You could switch to x and y. Now I would probably still rewrite. I would probably still rewrite, just to make it easier. But you could switch to x and y. There's the inverse. Take the derivative. 1 equals 3y squared plus 4y to the negative 2, which would be 3y squared plus 4 over y squared. Now hold on, pause. Who have I forgotten the poor little guy? I killed my bunny. Why am I pulling out a dy dx? Because I took the derivative of this whole y expression. Technically, he had a dy dx and he had a dy dx. So I just factored him out. So how would you find the dy dx when y is equal to the inverse?
Well, it would be 1 over that whole thing. Equals dy.
This looks kind of familiar, right, guys? What's different? I need the y. What? What do you mean? Oh, but I knew all along who the x was. The x is 6. So if for the inverse, if the x is 6, who is the y? Do you still have to go to the beginning and somehow figure out who the y is? Plug it in, plug it in.
Although it's better, it's easier on this side, you still have to find
You
the
still
y.
have to do the tricky step over here of finding the b. But for some of you, the notation is a little bit nicer because it switched to x and y. Over here, you can plug in the x, solve for the y, and over here, take the derivative, which you're always going to end up with 1 over f prime plugging in the b. So for some of you, the implicit might make you go wrong. You might make some mistakes in that implicit, which would mess you up. The 1 over f prime gets you straight to the answer. Once again, why don't I just teach this one? Why don't I just teach the other one? Some of you, conceptually, this will make more sense. Because you switch to x and y, solve for the implicit derivative. Who's y? Well, I don't know, but I know x. Go find y. All right, plug it in. But the AP does force your hands, and at times, force your hand, I should say. At times, it makes you know this formula, and switching x and y is not enough. Any questions on what it is? Or?
For example, like, how did dy dx get to the other side?
Right here?
Yeah.
I divided, but I didn't. Usually in math, you always want like the question and the answer. It's like f of x equals or y equals. So I just went ahead and divided, but then I switched the order. If a equals b, then b equals a. It's not technically part of the original.
Reflexive.
Let's just delete this page. I don't think you guys need it, because we already did. Well, maybe I'll undo that just in case with juniors tomorrow I decide to do something as you guys are, I don't know, doing like okay-ish, but let's just leave that off. Yeah, let's stop there. Does that sound good? This one's going to be a little tricky as far as finding the b. This one's going to be a little tricky as far as finding the b. But let's get you into homework. I'd say let's get you into homework. Kiddos, if you need to use one of my books, you can, well, let's first get the assignment up. Some of you started it last night, some of you did not. Those of you that were working on other things, I'm not going to force you to do math right now. So if now you want to be working on something else because you need to, that's okay, especially if you did homework last night.
So now it's
Huh?
The test.
Yeah, I'll get them up. I was getting you guys started on stuff.
Oh.
Let me get the homework assignment up. I'm also opening the book, just in case, because I do have 4 more.
Misty, I need like a piece of cardboard or something.
Oh, you can look in that cupboard. That's my random junk decorating cupboard. It's possible.
Because otherwise, this one.
Alright, kiddos, yeah, I'm freezing the screen. So if you want to write down the homework assignment, if you did not start it, go ahead and get it down. I'm also opening up your book. People in the video, sorry, go back and pause if you need the homework. Let's see, I don't know what I got. Wait, Tyler, look in the cupboard right next to the cart on the right-hand side. I think there's like a random box holding pepper cake. Grab it.
Yeah, except I need it for like my spiral cover.
Oh, yeah, if you
Or
want
else it's
to.
gonna fall apart. So
I don't even know what that's for.
oh, there's a
empty
smaller box.
Yeah, use that one.
So even though it's really bad, I don't care because otherwise the spiral is gonna be like 10 pieces.
Anybody still writing down the homework assignment? Oh, sorry, a couple more seconds. I apologize. I'm getting up your ebook.
Don't worry, Eris. I'm just saving my spiral.
We're very proud of each other. I don't know how you're gonna do it though. Are you gonna like actually
Just
punch
tape it
holes?
on or something.
Oh, okay.
I don't know.
What are you trying to do?
It stops the paper from ripping out because the back cover of my spiral fell out. Or it fell out.
Alright, for those of you that don't have a book, I am, here we go,
17.
trying to get you how you can start on homework.
It's a huge piece of paper. Don't you think?
Okay, people watching the video, I'm gonna go ahead and pass out the tests, because I told them I would, they have their correction
Do
papers
that.
already.
There's all the space back there.
Question. On the first test, did I allow some bonus points to come back for corrections?
I love that.
I allowed 1/2. I allowed 1/2 points back.
So give like a fourth back this time.
I'll go with third.
Ooh, generous.
As we move on, the content might get a little harder, but you guys should also learn a little better how to study for the tests, right? Doesn't mean this one went better for you, but
Oh,
you should be learning how to better study for the test. So you're going to be able to get 1/3 points back from corrections. So if you're wondering how many points you can get back, ready? Take 100%. Subtract your current score. Divide by 3. That's how many points could get added to your score. But you have to do the corrections perfectly. That doesn't mean you have to do it perfectly. Reach out, get help, get tutoring, come to me. I try to encourage you guys as much as possible to reach out when you need the help. So for corrections, do you need to do them alone? No. You're going to have like a whole week, you're going to have until next week to get your corrections done. It is important for moving on in calculus. A lot of you chain rule stumped up. Some did very well. I have a few over 100%. Is it a perfect score or is it
Did you say you had bonus points?
I have a perfect score. At least one. So, kiddos, there are people in your class that know how to help it. I am also here. I know how to help. You don't need to give me the chance. Okay? I can't do one-on-one tutoring in class, but I can outside of class to some extent. Or I can give you ideas if you're like, it's not working, please, I need help. Alright, cool kids, this is in absolutely no particular order whatsoever. I have like over 100s at the beginning and at the end. I have everything in between. Let's go and get this class back. Nathan, come on down. Tyler, come on down. Sean, come on down. Eris, come on down.
is it alphabetical?
Oh yeah, it might be. Never mind, it is in some particular order. I forgot that.
Wow.
Eileen
You like this,
figured it out. Denise. On. Austin. Sam. Charlotte. Lucy. David.
It looks like I have 1,010%.
Oh, she's gone. Caitlin's gone. Crystal. Sarah.
This is really inefficient.
Okay. Pause. Some of you, as soon as you see your score, it can lead you 2 directions. It can lead you to be cocky, to be honest. It can lead you to be completely crushed, or somewhere in between. Listen again. If you like it, reach out and be like, hey, I can tutor people. I think I kind of got this. If you don't like it, reach out and be like, hey, buddy, can we go ahead and work on stuff? Or, hey, Miss D, I'm coming in today. Or I'm coming in tomorrow during lunch. Or I'm coming in, just help me shore this up because something went wrong. Okay? Take your time. We'll go over these corrections. How long do you have on them?
A while.
Like a week. Next week's good. We'll let the juniors get back. We'll let them get their tests. Then we'll go ahead and make sure you guys have enough time to do corrections. The point isn't how fast you do them, it's how well you do it. But pause, one more time. Take 100%, subtract your score, divide by 3. That's how many points can literally get added to your score. If you just take the time, meet with people, meet with me, and make sure your corrections are perfect. Sound good? Take 100, subtract your score, divide by 3. That's how many points literally can get added to your current score. I'm going to go ahead and stop the video. If you guys have Almost 15 minutes. I was pretty close. We got the test pass back.